So basically, we're approaching the end of this topic. We kind of spent a lot of time on chapter 9 about endangered species, and then we moved on to chapter 10 on preserving ecosystems, and now we're going to kind of continue on that same idea of preserving ecosystems, except now we're going to go underwater. So grab your mask and snorkel. And here we go. So my plan, if you didn't see, is to have our exam on this topic on the 25th and 26th, depending on if you're a group 1 or group 2 person. Okay? It'll be, good question. Formats will include an FRQ along with mostly multiple choice, but one FRQ with multiple parts. Okay? It will be on all 3 chapters, yeah. Chapter 9, 10, and 11. This is actually 11 in our book, right? It says 12, but it's actually 11, so don't worry about that. Okay? Yeah. Go to the files and then find, I think we're in Unit 5, Sustaining Biodiversity. And I think you're going to have the longer version of this PowerPoint. So I think there are slides on the one that I posted that I'm not going to talk about today. Okay? Just because there's not enough time to talk about everything. So, I mean, any one of these things you could spend a lifetime studying, I think, huh? It's amazing. So, we're going to do this PowerPoint. We're going to do some activities over the next couple of days, like Friday and Monday. And then I think it'll be test time, Thursday, Friday. Does that sound right? Yeah. So test is a week from Thursday and a week from Friday, it looks like. Okay. So when we're talking about sustaining aquatic biodiversity, here's some big ideas, some overview questions to think about. Basically, aquatic includes both in the ocean and in freshwater, right? Both marine ecosystems and freshwater ecosystems. So we want to consider the ocean issues, and then we want to consider the freshwater issues, and then we subdivide those into lentic and lotic. What were those? Do you remember lentic and lotic? One is the flowing water, the moving water, a river. That would be lotic. And the lentic zone is a lake. Yeah, like Tahoe is lentic. In addition to that, we want to consider wetlands, which include marshes and swamps and bogs, and their biodiversity. Highly endangered ecosystems in general of the wetlands. Some more questions. Yeah, so you can see we've got these ocean issues, then we have freshwater issues. Here is a case study. Remember I talked about having a toolkit or a bag of tricks. And this one case study of biodiversity is Lake Victoria, which is a huge lake in Africa, the size of Lake Superior. And it has so much space that this one family of fishes called cichlids has diversified into many species. People happen to like these species for their aquariums too, because they tend to be colorful. They tend to do well in an aquarium. However, the different species don't always get along very well, so you're going to have to specialize in one or another. Now, this leads to an issue. You know, one of the parts of the extinction graph mentioned capturing animals as pets. So that is something when it comes to keeping an aquarium or having birds in a cage at home, or reptiles or amphibians, were they raised in captivity or were they caught in the wild? To me, that's an important distinction. So I kept an aquarium for many years. And then after thinking about it, if they're capturing them in the wild, that's going to impact those populations. And to me, it became a choice that I didn't want to have that impact, with the exception that I thought it was worth it to have an aquarium in my classroom um, for its educational content instead of my personal entertainment at home, to use it to share some of the biodiversity of the world with my students made it more valid for me. So there's all these ways to look at different value judgments, huh? When is something okay? When is it not okay? It's going to be different for different people. And that's kind of where I drew the line. And then I still tried to focus on captive raised fish instead of wild caught fish. One of the big issues in Lake Victoria is an introduced species. Look how big that thing is. This is called the Nile perch. And that was introduced into Lake Victoria. This family of cichlids, these guys, they're aquarium fish. They range from maybe an inch long to maybe 6 inches long. And then this thing got introduced there, and you can tell it would be a pretty voracious predator. There was also an introduced plant there, the water hyacinth, and you can see how that covered the surface, which would then impact the amount of light getting into the waterway, potentially use up nutrients. And if it wasn't a species that was eaten by any of those natives, then it would just grow out of control without contributing to the food web. So introduced species are a big problem in many freshwater ecosystems, including Lake Tahoe. So Lake Victoria has lost a lot of biodiversity. The Nile perch, the algae blooms, the water hyacinth. It looks like the Nile perch is eating itself out of a new home. Let's talk about these algae blooms, because this is an issue at Tahoe. You've all seen and probably have the stickers that say "Keep Tahoe Blue," right? What does that mean, to keep it blue? Largely, it means to keep the water clear. Because the deeper that the light penetrates, as light penetrates water, different colors of light are absorbed. And the first one that's absorbed is red, and then orange, and then yellow. And so when you're underwater, you don't really see reds and oranges and yellows because they've been absorbed by the water in the shallower levels. You go scuba diving down to 50 feet, whether it's in the lake or the ocean, things don't look that colorful anymore unless you bring a light with you. Or if you're taking photos, you use a flash to light things up, huh? And then the colors come out. In fact, many of the nocturnal fish in the ocean are bright red. But at nighttime, with a lack of light and the red light being absorbed, they're almost invisible. But if you shine a light on them, they're this bright red color. At any rate, as the water's penetrating Tahoe, these colors are absorbed, and the deeper the light goes, you also lose the green colors, and what's left to reflect to our eyes is the blue. That's why Tahoe looks blue. A lot of people think it's because, it's reflecting the sky, but isn't the sky also cloudy and gray, right? It's really blue because different wavelengths of light are absorbed or reflected. It's the blue that's reflected and comes to our eye. And the deeper the light penetrates, the better that blue color is going to be. Now, if there's things clouding the water, such as sediments or algae, that's going to reduce the penetration of the light, so the lake's going to look more green. That's what we're talking about, keeping Tahoe blue. It really should be keep Tahoe clear. So algae, this stuff grows for a variety of reasons, from nutrient runoff, in other words, from fertilizers. Nutrients help the algae grow, just as fertilizers help grasses grow. Sewage, well, feces have nutrients in them, whether they're from people or dogs or whatever. And then these fish that were eating the algae and keeping it under control have died off. That's not an issue here, but we do have some invasive species that are altering the balance of which algae we have and which organisms are eating the algae or not anymore. So we introduced intentionally a shrimp that's maybe this big, bigger than our native. We have zooplankton in the lake, small zooplankton, big enough to see naked eye, maybe the size of a period. Some of them are bright red, and we think that's like a natural sunscreen that they have. And they swim around because they're animals. They're related to shrimp. But they decided to introduce this other shrimp called a mysis shrimp into the lake around the 50s, I think, because they thought it would help feed the fish that people wanted to catch from the lake. Well, it turns out that the mysis shrimp during the day, they swim down to the bottom of the lake where it's completely dark, and the fish don't find them, and they only come up towards the surface at night, and the fish aren't active then. So it didn't really help our fish. But meanwhile, the mysis are eating these smaller zooplankton that were native to the lake. So now there's a suggestion, how can we get rid of the mysis shrimp? Well, let me back up. They're eating the mysis shrimp, the introduced one, are eating the native zooplankton, right? Which used to eat the algae. So if the mysis is eating the natives, the algae is not getting eaten, and so we're getting more algae, and the lake is less clear, less blue, right? So we want to get rid of mysis shrimp. A recent suggestion is we go out on the lake with these nets that will collect the shrimp. Again, they're only this big, so you have to have the right size net for it. And then they want to turn it into dog treats, like high-end, upper class scale dog treats, Tahoe shrimp dog treats. So who knows whether that will happen or not. Oh no, it's meant to feed your dog. Oh, they're so tiny, I don't think people would eat them. However, another idea that was recently, you know, the crayfish that are down there, the crawdads, that you see in the lake, right? You probably caught them when you were a kid, right? They are not native either. They were also introduced to the lake, and they have an impact by concentrating nutrients, which feeds the algae, which reduces the, right? We got this whole chain of events. So I used to see kids like catching them and putting them in a bucket, and I'm like, oh, yeah, they're gonna die because they're gonna get too warm because they need a lot of oxygen and cold water. And now I'm like, yeah, catch them and put them in the bucket because they are an invasive species in Tahoe. Not terribly invasive, but they are. And so there was a company that opened up maybe 5 years ago that was going to trap the crayfish and then sell them to restaurants around the lake. Because crayfish are big enough for people to eat. Very commonly eaten in the South, in fact. And they called them Tahoe lobster. But apparently somebody vandalized some of their traps. Enough of them got vandalized that the company just gave up. And I don't know if they had enough demand from restaurants to serve the Tahoe lobster, which of course depends on people ordering it, right? Once again, another chain of events. Okay, so how much of this overlaps with HIPCO? Aquatic species are threatened by. Is that pretty much HIPCO? The only one missing, oh, all made possible by the human population. It's not missing, is it? This is HIPCO, isn't it? Right? And just something to think about. Wouldn't a nice, shall I say, appropriate might be better, an appropriate or relevant type of FRQ ask you to describe HIPCO and what it stands for and such? Just maybe. So we have a lot to learn about aquatic biodiversity because we can't see it very well. It's difficult to explore. We do have some patterns though. We have high diversity in those habitats And we see more biodiversity near the coast, and we see more biodiversity near the bottom. Think about it, a lot of creatures don't swim around that much, right? They live on the bottom, or they live on the beach. So we have more biodiversity where there's something for them to attach to. I think we might have talked about the pelagic zone being like an underwater desert because of the lack of biodiversity, and just because the animals are very spread out in the open ocean. Human impacts. We've destroyed 20% of the coral reefs. I don't know if any of you have been scuba diving. It's an awesome thing. I highly recommend that you get trained properly because you got to be safe, right? But it's amazing to go scuba diving. For me, it was amazing. I didn't care whether it was a coral reef or the kelp forest. If I had the right gear, I'd also be happy to go like diving underneath the ice caps. Yeah, it might be scary. We did some diving in some caves in Mexico, which was incredible, but scary because you can get trapped in there. So we went with a guide for sure on those ones. But if you get a chance, go scuba diving. And I don't know, as we're seeing the diversity drop, it's kind of like the sooner you go, the better. So, remember I mentioned mangrove forests when we studied biomes that grow along the shoreline, right? And the roots grow down into the water, even though they're a tree. And it's great habitat for fishes to lay their eggs. Hey, by the way, when do you say fish and when do you say fishes? Like, oh, there's a school of 300 fish. There's a school of 300 fishes. Why do I use one in one case and the other in another? It has to do with the number of species you're talking about. If it's a school of 300 fish, it's a single species. If it's a school of 300 fishes, it's multiple species. Okay?
Wait, say that again?
Yeah. So a single species, and you're talking about lots of individuals, fish, right? But if you're talking about more than one, it's fishes. So if you go see somebody's aquarium at their house and there's only 3 fish in there, but they're different species, you still say fishes.
Okay.
What nice fishes you have. But if they have another aquarium, one species of 200, then it's what nice fish you have. So the mangrove forest, a very important environment for juvenile fishes of many species. Okay, here's a before and after. Remember I mentioned when you were looking at yesterday when everything was not working online, and I asked you to read that article, and I wanted you to look for the different types of fishing. This is another one. It's called trawling. So imagine just dragging a big weighted net across the bottom and filling up the net with whatever you scrape up. It's kind of like a bulldozer or a snowplow, except that pushes, and this is more like scooping it up by dragging it across the bottom. This is what's left. This is how we get tasty things like scallops. But then how much of this other stuff did we not want and they just throw overboard? All that stuff is called bycatch. Pick up on that yesterday? Bycatch is the wasted life that you accidentally caught. You're not trying to catch it, you're not trying to hurt it, but you're not going to stop doing it if it gets in the way of your profits, right? So a lot of bycatch results from trawling. Now, here's another example of keeping the lake blue. Here's a lake I think in Wisconsin or something, and notice that there's like a square in the lake, right? This is where they set up a net that kept this fish, the carp, related to goldfish, it kept it out of that area. And as a result, look at the difference in the lake. Here it's all green because with the carp, it helped the algae grow more, huh? And so the lake went green, whereas the lake was supposed to be more of this blue color. And this was, I believe, an invasive species in that lake. And here's the description. I'm not going to go over this in detail. However, I will say this word right here, turbidity, Later on in the spring, we're going to do some water testing, and I hope we get to do some turbidity tests, which is how clear the water is. If there's a bunch of sediments in the water, we say it's turbid. Okay, if it's clear, we say it's low turbidity. And generally, a river or a creek would have higher turbidity than a lake because the sediments have time to sink to the bottom in the lake. But in the creek, the water is always getting mixed up, so it has higher turbidity. But you could see that the lake was definitely not very clear except where they kept the carp on, right? So this is talking once again about invasive species. Wow, 2/3 of the fish extinctions in the US in the last 100 years from invasive species. And then we have pollution as well. In Tahoe, in addition to those invasive species, we have some problems with small clams and other mollusks that we're trying to prevent from getting here, like the zebra mussel. We don't want that to get here. They grow very prolifically. There's photographs of like a boat propeller that was moored in a lake with a zebra mussel infestation, and the whole propeller is just covered with shells attached to it. And another photo I've seen is like where a water pipe is either going down to the water or coming out of the water to bring fresh water to people, and it is filled with mussels. Water can't even move through the pipe anymore. So this is a big problem we're trying to keep out. We already have the Asian clam is here. If you go down to like Nevada Beach and Marla Bay down there on the south side of the lake, you will see these small clam shells about the size of my thumbnail. And those are not native here. And they impact the clarity because of what they do with the food web. Plus, you don't really want to be walking on those shells all the time. Okay, so I was describing this process where the lake becomes less clear because nutrients are added to it. The vocabulary that you should know is eutrophication. I think I mentioned it before. A eutrophic lake is one, literally this means true feeding. Troph is feeding, like a trophic level, the feeding level. Eu means true. So this is a lake that is truly fed, and it's fed with nutrients, and that causes the algae to grow. The lake becomes less clear. So eutrophication is the process where this occurs. That's one form of water pollution. Another form is industrial pollutants. And when we study water more directly, we're going to talk more about these different kinds of pollutants and what they do and where they come from. And of course, we have plastic issues, right? So it might just be ugly, or it might actually be harmful. And we're discovering new ways that it can be harmful, like when it breaks down into even smaller pieces than this, how it can be absorbed into the food web. And also the plastic tends to hold on to these molecules that mimic hormones. So as animals are eating these tiny bits of plastic, it's like adding estrogen or adding testosterone to their system. The Great Pacific Garbage Patch. We talked about this, right? Trash soup the size of Texas.
But why is it even there?
Okay, well, it's there. First of all, some ships dump their garbage overboard, including some cruise lines. So it's like some people would boycott a certain cruise line if they knew they dumped their trash overboard, right? And then there's the other types of ships that are not for passengers, that are working ships. What do they do with their garbage? Then there's garbage that just gets blown out to sea by the wind. Then there's garbage that gets carried out to the sea by rivers, right? So theoretically, you could go to Tahoe City and drop, I don't know, a tennis ball. You're throwing your tennis ball for your dog, and oh, the dog lost it, and it went down the Truckee River. Where's it going to end up? Maybe in Reno, maybe all the way down at Pyramid Lake, huh? If we had a river that went to the sea, it could well end up there. So that's another source of garbage out in the ocean. Then, of course, there's all the cities that are right on the coast, and their garbage can end up there, sometimes intentionally, sometimes accidentally. When the plastic breaks down into these tiny pieces, they're called nurdles. Did we introduce you to this word before? It's such a cute word, nurdle. Basically, think of a tiny bead of plastic. So when they're making plastic from petroleum, from crude oil, the first thing they do is make these nurdles. And they have these buckets of these little beads of plastic. And then you can pour them into a mold and melt them into whatever shape you want. You know the way styrofoam breaks apart into those little balls? Think of it like that. So here's a map showing the Great Pacific Garbage Patch, actually two of them. And what happens is there are these currents that spiral around. This is called a gyre. So where the current spirals around, it drops off the garbage there, and it tends to build up over time. Now, it doesn't extend all the way to the bottom. This is all floating garbage, right? So there's some images.
Wait.
This one's underwater.
There's multiple?
On the bottom left, but underwater. Look at this guy. Now, I don't think he's in the Pacific Garbage Patch. He might be in a river somewhere. And then these people taking their boat along. Again, I don't think this is out in the middle of the Pacific.
Oh my
But
god.
it just kind of shows you where's this garbage going to end up. Eventually, it gets washed out to sea. And there's an image of the nurdles. Yeah, there's a lot of work to be done, huh?
Yeah.
Okay, well, we were doing HIPCO, so here's our climate change issue. Sea levels rising, aquatic biodiversity threatened. We talked a little bit when we studied pH. We talked a little bit about ocean acidification, where as we add CO2 to the atmosphere, the carbon dioxide dissolves into the water and it lowers the pH. It makes it a little acidic. And as a result, that acidic water can prevent animals from building their shells. And that includes coral, it includes clams and oysters and scallops. Anything with a shell may have a difficult time if we lower the pH of the ocean too much. We may lose some coastal wetlands. Here's our explanation of acidification. The warming of the ocean is also threatening coral reefs. Many of them are going through what we call coral bleaching, where they lose their color. A lot of that color is from algae that lives inside the coral symbiotically. And when the coral is not feeling healthy, it will expel that algae. And so then the coral is just pure white. So it's coral bleaching. A little more discussion of mangroves. It's a natural protection against tropical storms. That would help us in many ways if we preserve them. The only thing is, if you cut down the mangroves, you often end up with a nice sandy beach. Like Cancun used to be all mangroves, but now it's all beaches. Probably getting filled up right now with spring break. Here's an image of mangroves showing how they have these roots that go underwater. And then we've got the issue of overfishing. There are some people that think we should just stop eating seafood altogether because of this. So this is a problem for both marine fish and freshwater fish. At Lake Tahoe, it's already too late. There was naturally occurring only one species of trout here, the cutthroat trout, and they were huge. And people caught so many of them in the early 1900s, either with fishing poles, or at one point we even had people coming out here with nets on their boats and gathering up these big cutthroat trout and taking them to San Francisco on the train to serve in restaurants there. Now the cutthroat trout from Tahoe has gone extinct, and they replaced it with several other types of trout that are not native here. And that's why they introduced the mysis shrimp to feed these other fish. Now today they are trying to return cutthroat trout to the lake. And one of the problems is that the native trout are usually bigger and more aggressive and will eat the young native cutthroats. So we did fish them to extinction. You should be aware of this phrase. It might be about fish or it might be about anything that we harvest. Commercial extinction. It doesn't necessarily mean that they're completely gone, but it means it's no longer profitable for us to harvest them. There's not enough of these species for us to bother trying to catch them anymore. Or if it's a type of tree, it's not worth us trying to cut it down anymore. I already mentioned bycatch, right? We catch things that we don't really want, like dolphins would be considered bycatch when it comes to tuna. We're not trying to catch the dolphin. So if you're a fan of seafood like I am, I like to eat sushi, and I like to eat salmon, and it's also healthy for me. However, there's issues, environmental issues and sustainability issues. So, for example, the bluefin tuna. You may have read that there's like 15 types of tuna, right? They would not use bluefin tuna to put in a can. That's the best of all the sushi fish. In fact, one large fresh bluefin tuna might bring $100,000. A single fish could now be worth $100,000 in the Japanese market, which means that people are motivated to go catch it, aren't they? Which means that there's not very many of them left, which raises its price up more, which increases the motivation to see how this spirals on itself in a positive feedback loop. Yeah, I don't know. I mean, it takes time and effort, and it might be enjoyable. I know, for instance, Mr. Kivo just a few months ago went fishing off the coast of San Diego. No, not spearfishing, just line fishing with a pole, catching one fish at a time. And I think he caught a bluefin and brought some back. Yeah. So,
My family lives in
all
they do is fish.
Oh yeah.
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 So they eat a lot of shrimp.
Uh-huh.
And all types of fish.
Right.
And, like clams.
Uh-huh.
And a lot of stuff.
Right. Well, what happens if we're catching only the big fish and we're putting the small ones back, which is what the laws often tell us we have to do, right? Mm-hmm. It has to be this big before you can keep it, correct? Mm-hmm. But which ones are the ones that are breeding? The big ones, right? And those are the very ones that we're targeting. So what could that do to a population of fish if we take all the breeding ones out? Or what if it's a species that takes 25 years to reach maturity? It has to avoid being caught for all that time. Like some fish that are, yeah, some fish that are sold as red snapper are not actually red snapper. There's a type of fish called a rockfish, and they can live 100 years. And so what happens is the older rockfish are all fished out. So overfishing is a big issue. Here's some different types of fishing. Take a minute to read through those. Ask me if something isn't making sense to you. Most of these are pretty clear by their names, as long as you know that trawling is dragging something on the bottom. Purse seine to me was always a confusing name. Apparently, a seine is a type of net. And the purse is like, it has a drawstring, like on a purse, that you can close it up, except the drawstring is on the bottom. So the boat circles around the school, dropping this net as it goes, but the bottom of the net has like a wire that they can pull up, and therefore it closes the net underneath the school of fish. It closes from underneath, and then they pull it up. Anybody ever watch, it's a pretty old movie now. I think Clooney was in it, George Clooney, Perfect Storm. Okay, so it's a pretty amazing movie. I think it's based on a true story about these fishermen in the northeastern coast of the US. And they go out, and it turns out like 3 storm systems closed in at the same time. And I believe they were lost at sea. But there's some nice scenes of how they're fishing, and they're doing long lining. And it's like this, the boat is going along, and this line is coming out the back of the boat, and there's a guy back there, and there's one hook after another, and he's hooking a little bait fish on there, maybe this big, and then dropping it overboard, hooking on another one, dropping one after another. Very dangerous. And then the guy hooks his hand, and he gets dragged into the water because his hand is in the hook. So dangerous thing. And another guy, of course, dives in and saves him. But anyway, that's what I always think of when I think about long lining. Is that image from that movie?
I don't know. I don't remember how my uncle's fish.
Yeah.
I literally went with them.
Yeah. Well, this was totally commercial fishing, not just for their family, right? They're trying to catch hundreds and thousands of pounds of fish and then sell it when they get back. And they have like a big hold, a big storage in the boat filled with ice to keep the fish fresh. Okay, and so here's some diagrams of these different types. Here's the trawler being dragged along the bottom. It's kind of hard to tell. This should be on the bottom. Sometimes they use an airplane to find where the fish are. Or if you see lots of birds flying around and diving in the water, that's a sign that there's small fish there. And if there's small fish there, then underneath them is probably a school of big fish, right? Here's the purse seine, which has now been closed. The drift net, the long line. And then we have these types of fish farming. Some types of fish farming are sustainable and some types are not. So for example, let's just say this one, what happens to all the wastes from these fish? Basically, it gets stuck right there. At least if there's no current to carry it out to sea, it would just build up there. Sometimes they put these in a bay, and that could be really bad for the bay. So there's different types of fish farming, and some are good and some are bad. Okay, what can we do? We can use laws. We can use economic incentives. We can create marine reserves. Okay, some of the issues involve the ocean uniquely because so many different countries want a piece of it, right? So, for example, there can be a fishing fleet from Japan that goes up the coast of Mexico to catch fish and then bring it back to Japan. And we have these laws about where that's permissible. Generally, I think it's like a 200-mile limit. Sea turtles are incredible creatures. If you get to go scuba diving with one of them, it's very fun. Yeah.
I was just swimming, my brother's like going down, and I was swimming right above one, which is like
right
feet below me, and I freaked out.
They're big, huh? Yeah.
What's the turtle from
From
Nemo?
Nemo? It's, I don't know which species it is, or if it's actually an accurate species. There's green turtle, there's leatherback, there's hawksbill. I don't remember all 7 off the top of my head. Threats to the leatherbacks. We talked about the turtle excluder devices already, right? The TEDs. I'm going to keep going. This is a case study about sea turtles. And then there's whaling.
Yeah, it was a sea turtle. Oh, shoot.
So, for a lot of years, people were catching whales for a variety of uses, somewhat for the meat, largely for the oil. Now we have alternatives, and so we don't really need to be whaling anymore. Commercial whaling was banned in 1960, but some countries continue to catch whales.
Is that it bleeding?
Yep, that's blood in the water from where it's been harpooned. Yeah. That means there's a lot of oxygen in that blood. I don't know if you know that there are 2 groups of whales. There's the ones that have teeth and the ones that have baleen. Imagine taking hair and weaving it into a material that's almost like plastic, except the edges of it are kind of fraying away into the hairs. That's what these baleen whales have in their mouths. And those hairs act as a filter, so they eat huge amounts of tiny creatures, like shown, the fin whale is shown taking a gulp of a bunch of little shrimp, huh? And so they can expand their throat, fill up their throat with gallons and gallons, hundreds of gallons of water. They close their mouth, and then they squirt the water back out, but it's going through the baleen and trapping all the little food bits inside, along with any little bits of plastic that they happen to have in their gulp too, right? Yeah, the plastic is not providing with any nutrients, and it doesn't always move all the way through their digestive tract. If it's big enough, it can get stuck in their stomach, and their stomach gets to the point it can't take in any more food. 15,000 gallons? That's like a swimming pool. It's like almost as much as this room, I think. One mouthful. Okay, marine reserves make up a tiny percentage of the world's ocean. This would be places where we, for example, don't allow fishing to occur, right? And fishermen, of course, are not always in favor of this, but there's some other benefits. One is you can increase tourism. It also turns out that, let's say you set up a marine reserve. Let's say you've got some big islands, right? And you set up just the southwest corner of it as a reserve. No fishing in this corner. What happens in that corner? The fish grow to adulthood there, right? They breed. Where do their babies go? They spread out around the island. And you can actually have an improvement in your fishing by protecting a nearby area from fishing. Seems counterintuitive, right? That if you reduced fishing here, you might have better fishing next door. But that's what they've found has happened with some of these marine reserves. Okay, in this, these guys are trying to rebuild coral reefs. So here's this structure that they're attaching little fragments of coral to. And over time, it's growing into a full-on reef. So they're trying to restore the reef or build a new one in another area. Here's another way to make a reef. You have an old ship. What are you going to do with it? Well, if you take all the polluting fluids out of it and then sink it, it actually provides a place for coral to attach to that attracts little fish. And scuba divers also like to dive on these old wrecks. So here's people diving. It looks like it's sideways, huh?
I always thought
How about this one? Can you see what that is? That's a tank. This is like from one of the Japanese, or I don't know if it was American or what, but it was during World War II when we were fighting Japan, and somebody's ship sank and it had tanks, and you can go scuba dive on the tank. And the battleships have their big guns and stuff. But now, of course, they're getting covered with coral. So this is another way of building an artificial reef, providing a surface for the coral to attach to.
Yeah, maybe there was like I think it was you changed it to that. They had this episode where they were taking a bunch of car frames and they're trying to just throw them in the water to see if they can grow coral reef on them.
It's
So
possible.
they just kept failing and like dropping on their boats and then it would wash up on shore.
Yeah, here in our country, we do this intentionally sometimes, but I'm sure there's a huge permitting process. I know they've done it off the coast of San Diego. Okay, here's some of the legal terms about where you can fish and where you can't. Within 200 miles of the coast is what we call an exclusive economic zone. So let's say that I'm an American fisherman and I have my ship and I want to go fishing off the coast of Mexico is where the fish are. I cannot go within 200 miles of the coast to be legal. Let's see, marine protected areas, like a wildlife refuge. Here's another phrase, the high seas. That means beyond the exclusive economic zone, where it's open for anybody to harvest fish or to drill for oil or whatever. So it's kind of a free-for-all. It's a good example of the tragedy of the commons. There's no regulation of who's using what. A little bit more about marine reserves. Some things are allowed, some things aren't. Dredging is when we're digging up the bottom. And we might dredge a harbor, for instance, to make it deeper for the ships to get in and out. Or we might dredge to get sand to build something with. I think this is what I talked about earlier, how a fully protected marine reserve can increase the population, so the new fish actually spread out to areas that aren't protected and help the fishermen in that zone. So this can boost the local fishing economy. If they stop fishing in one area, it might help their fishing in another area. Here are some suggestions for how to modify U.S. ocean policies to be more sustainable. I think I'm going to keep going on from there. What do we need to do to sustain our fishery? This phrase fishery refers to the economic aspect of fishing a particular species. So we can talk about the tuna fishery is different than the shrimp fishery, which is different than the salmon fishery. So the fisheries are all those different choices. So some of the things we could do are monitor our fish populations, work with other countries, reduce subsidies. Subsidies are when the government basically is paying the cost of the fuel for your boat or something like this. And then careful consumer choices in seafood markets. So one thing that I asked you to read about yesterday was Seafood Watch, which is from the Monterey Bay Aquarium. And the Seafood Watch is basically gives you advice on what kind of seafood to buy or not. So, like, here's a little card that shows red, yellow, and green choices when it comes to seafood. So I'm seeing that orange roughy Chilean sea bass are red. Sea scallops, lingcod are yellow. U.S. farmed shrimp, Pacific halibut, mahi-mahi are green. Now, some of these, it depends on how they're caught too. It might be that this same fish from one place is caught using a method that's okay, that's sustainable, but from another place it's not. So it becomes pretty difficult. So I have a bunch of these if you want one.
I want one.
Or, yeah, you should send it to your family. Or if you like, go online, go to the App Store and look for Seafood Watch. I have it on my phone, so when I go out to dinner and I want to get seafood, I always pull up the app. This drives my wife nuts sometimes. I pull up the app and I'm like, oh, can't eat that. I'm like, yes, I can eat that. So I can search right here for tuna, and it really depends on how it's caught and what type of tuna it is. Some of it's green, some of it's yellow, some of it's red.
Who's octopus?
Octopus? Oh, well. What is an octopus?
No, where is it?
Oh, where is it? I don't know. It might not be on there. So maybe it's on this app. And the nice thing about the app is they update it all the time. Let's see. Is octopus on here? Or isn't that taco? Octopus. I think it's called taco in Japanese. If you go to a sushi restaurant and order a taco, you're going to get octopus. Yeah, yellow and red. Here's a green though. Most of the octopus, including Mexican octopus, is yellow or red. But here's one from the North Pacific that's green. Octopus are very smart animals too. So,
Yeah.
did you ever? There's a new show on Netflix, My Octopus Teacher. It's a pretty amazing show.
I'm gonna watch it.
Yeah, it's a series, and this guy, I think he's on the Mediterranean, maybe in Spain, and he goes swimming like every day, and he notices this octopus in the same place every time he goes, and so he starts hanging around the octopus, and they start making contact with one another, and it's like the octopus recognizes him, and he bonds with this octopus, and learns all kinds of things about nature from it. So. It's pretty cool. My octopus teacher. Anybody else want one of these?
I think this is
Meant to fold up and go in your wallet or your purse.
yeah, folding it right now. Thank
You want an extra one to send to your family? Cool.
you. Look. I've never eaten squid. Is it good? Cause
Calamari? Have
squid.
you had calamari?
No.
That's squid.
Oh.
One way that they cook calamari is they chop up the squid and then they deep fry it, and then you dip it in a sauce, and it's often an appetizer. It's pretty tasty.
I'm thinking. No,
Yeah, sometimes you can see the tentacles all like coiled around, and other times their body is kind of like a long cylinder, so you get like this tube-shaped piece of calamari. I think that's the Italian name for it. Yeah, it's sad for the octopus and for the squid. Okay, here's some phrases you should be familiar with in terms of fishing. The first is not just for fishing. Actually, none of these would be only for fishing. But I would particularly like you to know this phrase, maximum sustainable yield, which is the maximum amount that you can harvest year after year after year without the population crashing. It's a sustainable yield, a sustainable harvest, and it's the most that you can do. They would use it when talking about logging as well, maximum sustainable yield. How much of the forest can we cut down and have it grow back at the same rate that we're cutting it down? Another one that we'll see time and time again is the last one on here, the precautionary principle. If you don't know what will happen, maybe it's best to avoid that problem or that issue in the first place, or at least to proceed slowly until you understand the system, which is one reason that we're all wearing masks and there's only half of us in the building at a time, right? We're trying to be cautious, better safe than sorry, right? And the same thing can apply to ecosystems. Yeah, I'm wondering about April myself. Right after our spring break. Right?
Exactly.
Yeah.
April? Yeah.
April. The return to full class sizes.
It's just, I thought
Which
it was
this is
70
almost full anyways.
I thought it was
70,000.
75%. And they're saying everyone can come.
Yeah, I'm not sure.
So, I don't know.
If I heard him talk about 75. Also, I'm gonna move on from this ITR. Consumer choices. So I've mentioned the Monterey Bay Aquarium Seafood Watch. I just gave you that little guide to seafood from the Blue Ocean Institute. Here's another good one, the Marine Stewardship Council. Here's the Seafood Watch. You can either get it as a card, very similar to the one you just got, or you can do it as an app, which I think they update pretty regularly as things change.
I'm gonna get one when I go to Mexico. I'm just kidding.
And here's one of my heroes, Dr. Sylvia Earle. She was one of the first biologists to use scuba gear back in the 50s. In 1970, she lived in an underwater dome with a group of other women.
Wow.
Underwater for like a month in this dome where they kept pressure on it. So one of the dangers of scuba diving is gaining pressure and then releasing it over and over again. So every time you go underwater, you get pressurized, and then when you come out, the pressure is released. It's even worse here at Tahoe because we're up high in the mountains.
What does it do?
What it does is it does a couple things. One, if you do it too fast, it can actually pop your lung.
Oh,
And that happens at Tahoe because people act like they're diving 50 feet deep because that's what their watch says. Their dive watch will tell them how deep they are. But because we're in the mountains, it's more like diving 80 feet deep.
Oh my
So you have to be more careful. The other thing it can do is cause something called the bends. I don't know if you've ever heard of the bends. But basically what goes on is that when you're pressurized and you release the pressure, so imagine taking a bottle of soda and shaking it up and not opening it. No problem, right? But if you shake it up and release the pressure by opening it, it bubbles everywhere. And so when you're underwater breathing pressurized air in your tank, the deeper you go, the worse this gets, the higher pressure it becomes. And if you come back to the surface and release that pressure too fast, the nitrogen in the air that you were breathing will actually form bubbles in your blood vessels. And it's very painful in your joints and causes people to bend up. And so that's why they call it the bends. But by living in an underwater dome that was pressurized, they were never releasing that pressure. And they could just go out to the water, come back inside the dome. It was like a submarine that was built on the bottom. Yeah. So they were able to spend a lot of time there. Yes. Yeah, you can die from the bends. Absolutely. She's also piloted different kinds of deep water submersibles and diving suits. At one point, she had the record for the deepest untethered dive. Maybe she still does. That means you're not attached to a ship. So when you go really deep, usually you're attached to something. There's a cable. She opened a business that builds small submarines. She has been creating these hope spots to protect ocean life and is featured in a documentary. There's one of these underwater laboratories that you could live in. here she is coming out of it, I think. Yeah, because you would like swim into the bottom here, and the air pressure keeps the water out. So you come in from here. Here's a diver right there, and you would come in from underneath. Yeah, yeah. Yeah, there it is in the background. So this is kind of primitive diving gear at this point, because this is what, the 60s or 70s? It probably wasn't very deep, probably 50 or 100 feet. Somebody inside, somebody outside.
She's having fun.
Yeah. And there she is in this kind of a diving suit, 1,250 feet deep.
She looks like an alien.
Not quite to the bottom of Tahoe. Tahoe's 1,600 feet deep. The gym suit. I don't know what gym stands for. Walking around for 2.5 hours on the bottom.
Oh, wow.
Oh, there she is getting brought back to the surface. It's like you are your own submarine, right? Here's another submersible. Oh no, that's her on the front of it, huh? She's standing on the front of that little mini sub. It's awesome, isn't it? Yeah. And I guess that's either suiting up or having the suit removed. So anyway, she's older now, but she thinks that the world's oceans are in such trouble we should stop eating seafood altogether. Other people think we need to eat more seafood to make sure there's enough food to feed the population, the growing human population. We should start eating more kinds of seafood.
Well, then, what do we do?
What do we do? Yeah.
That's tough. That'd be really hard for my family because that's all they know.
In fact, I think I included a quote from her like last week on my daily things.
Let me look. What's her name again?
Sylvia Earle. Dr. Sylvia Earle. What was I thinking of here? Yeah, so when it comes to eating seafood, sometimes they try to make the seafood, the companies try to make it more appealing to us. They start selling a new type of fish, and they might rename it in a way that people would be more willing to eat. So maybe you've heard of Chilean sea bass. The proper name for Chilean sea bass is Patagonian fangtooth or something like this. Patagonian toothfish, which doesn't sound so tasty, does it?
No.
But Chilean sea bass sounds pretty good. And that's on the red list if you look for Chilean sea bass like that.
It's right there. Patagonian toothfish high demand for this naturally long-lived fish drives depletion and creates I can't read. For continued illegal fishing. Oh.
So here's some solutions to managing our fisheries. On the left, we have what we could do in terms of regulations, some economic approaches, and what to do for protected areas. Oh, also consumer information. Some of these should be underlined because these are major topics. Here's the issue of bycatch, aquaculture, non-native species. So do you see how this should be subdivided into like half a dozen groups of topics for things that could improve what we're doing? I think that lists like these in your book are probably a good review just before the test because it's got a lot of information in a little space. Okay, that takes care of the ocean. So let's talk about wetlands. So wetlands are often considered kind of junky habitats. You know, they're mosquito infested and stuff like that, which is true. Mosquitoes breed in wetlands, it's true. But they also have a lot of benefits for us. They're important habitat. They provide flood control. So for instance, when there's big rainstorms, the wetland can absorb a lot of that liquid. But if you take the wetland out, it's just gonna flow downhill, isn't it? And this is basically what they've done along the edges of many rivers. Many rivers used to be winding, we call it meandering, and there'd be wetlands along the edges. And to improve navigation on the river, they've often straightened them out and deepened the channel, which means the water comes down faster. And when heavy rains arrive, the water doesn't have anywhere to go except up onto the land, which is no longer a wetland, so it's not absorbed. It's not like a sponge anymore. Even downtown Reno is like this. If you looked at the river in downtown Reno, it's got like cement walls on either side of the river. And if we have enough rain and snow at the same time, up here, it floods downtown Reno because the water doesn't have anywhere to go. When it used to be wetlands on the sides of the river that would absorb those floodwaters. It also filters the water. I think I mentioned this, but maybe not. We're going to be studying what happens to sewage eventually as part of our water pollution topic. Here, an incline, every time you flush or every time you use a sink or a shower, that wastewater ends up being pumped over the mountain to Gardnerville, south of Carson City. And there is a wetland there where the sewage is treated, first of all, to get all the really nasty stuff out, but it still has all the nutrients after the treatment, doesn't it? And so that is put into a wetland, and the plants growing in the wetland absorb those nutrients and clean up the water. So they provide nesting habitat for some animals. They provide food for other animals. Important habitat roles of wetlands. Sometimes people mitigate damage to wetlands, which means that they can destroy one region, but then their permit that allows them to destroy those wetlands means they have to create or enhance a wetland elsewhere. So in Reno, down in the Double Diamond area, when the Mount Rose Highway was extended down there, when the freeway was extended, they filled in some wetlands. But in order to be allowed to do that, those wetlands had to be enhanced. An equal number of acres had to be enhanced, and they did that in Washoe Lake, closer to between Reno and Carson City. So sometimes they mitigate, sometimes they don't. If it's private, then you wouldn't have to mitigate at all. You could just fill it up and turn it into crops, right? And this is in Washoe Valley. This is Slide Mountain right there. You guys know where we are? This is on the other side from us right here. So Slide Mountain. This is going to be like Diamond Peak over there. Okay. And so down here at the south end of Washoe Lake, they've built these wetlands. They've enhanced the wetlands. They've built these little, they built up the landscape so that it would trap water in a series of ponds, basically. So this is mitigation banking, which again, should we just preserve the original or should we try to restore something new? Which is easier? Which is more expensive? Which is more effective? So here's some things we could do to protect wetlands. One of the most famous wetlands are the Everglades, which are in trouble right now. Many of their birds have vanished. A lot of the water that used to flow through the Everglades has been diverted for agriculture and for cities. And the water that does arrive there often has chemicals in it that can cause these algae blooms. So here's the national park at the tip of Florida, the Everglades National Park. And then we have a water conservation area, and we have agriculture. So the agriculture is probably releasing fertilizers and pesticides that would be harmful to the park, but it is getting absorbed along the way. All right, that was it for wetlands. Are we good? Ready for lakes and rivers? Okay. A lake can be difficult to manage because it's a pretty much of a closed system. Now think about the water that gets out of Lake Tahoe is only from the Truckee River in Tahoe City. How big is that river? When you go stand on Fanny Bridge, how much water is coming out of it? Compared to the amount that's in the lake. Right? So how much of the lake is actually leaving and how much of it is getting refreshed? How long, I've heard a statistic, maybe you've heard this before too. How long does one water molecule stay in Lake Tahoe before it evaporates or flows downstream? The calculation is 700 years. Yeah. For one water molecule, it's going to be floating around in the lake, going down to the bottom, moving around. Now, some of them, it's 7 seconds before they get evaporated again, right? But other ones are going to be 7,000 years that they're here. So it's kind of trapped. This is true of most lakes. Here's the Columbia River in Washington State. So I don't know if you recognize Washington State here. Here's the river that forms, a big river, forms the border between Oregon and Washington. And then it has all these tributaries. The Snake River is one of them. Goes all the way to Idaho. And in fact, if you follow the Snake River, there's this one tributary that actually comes into Nevada, the Owyhee River. And this is a major salmon breeding ground. So the salmon they lay their eggs in these creeks, including like in Nevada. And then as young fish, they just follow the river downstream. They just let the current carry them out to sea. And then they'll grow bigger and bigger out in the ocean, maybe 2 years, maybe 5 years. And then when they're mature, they migrate back upstream to spawn in the same river they were born. It's a pretty amazing thing that they can find the same place where they hatched as a baby. The only problem is all these red and yellow dots are dams on that river, which makes it hard for the fish to get upstream as adults. It makes it hard for the baby fish to get downstream as well. So dams can give us lots of benefits. They make electricity without producing any carbon dioxide. They can reduce flooding, as long as they don't break. They can store water for a drought. They can provide water for farmers and for cities. But they also have this negative of turning a river system into a lake, which impacts the organisms that were adapted to the river. So on the Columbia River, we've seen a 94% drop in the population of salmon. Here's some of the ecological services they provide. I thought we had more to say about rivers and lakes. Perhaps not. Okay, I guess not. So let's go back to talking about the salmon and the rivers. One thing they can do to help salmon is whenever they build a dam, they build something called a fish ladder, which is more of a fish stairway. So imagine a set of stairs that you could walk over a 200-foot tall dam. And you have water flowing down those stairs that would allow the fish to jump from one stair to the next and eventually make it over that 200-foot dam. So that's what a fish ladder does, and it helps the adults get back upstream. But the problem is really for the young ones. Remember how I said they just follow the current to get to the ocean? Well, if you build a dam, how much current do you have? The water's not flowing so much, is it? So that can be a problem for them. We're going to take a closer look at salmon on next class on Friday. Okay. Do we have salmon at Tahoe? We do. Are they native? No. So we have a salmon, it's called the kokanee salmon. Have you heard about the kokanee spawning in the fall in Taylor Creek? You've probably been there on a field trip. I normally take my AP environmental kids there on a field trip, but you know what happened this year. It's not quite the same as when you go in 5th grade, when we go as juniors and seniors, but yeah, we would gather some data about the fish and analyze it and stuff. But so what happened here at Tahoe, for some reason they had a fish hatchery for kokanee salmon at Tahoe City, I think in the 50s. I don't know why they would have a fish hatchery up here without the intention of putting them in the lake, but apparently it accidentally overflowed, and that's how they got into the lake. And then they found their way to Taylor Creek and started laying their eggs there, started spawning there. And I think recently they've started spawning in some other places too. So they're an introduced species, but many people would not consider them an invasive species. So we could introduce a species and it might become invasive or it might not, depending on its impact on the ecosystem. So we do have salmon here at Tahoe, and we're going to take a closer look at them next class. All right. Questions? Different kinds of fishing methods. Which one was when they drag the net across the bottom? Start with the T. Trawling.
Trawling.
Yeah. And what's the one when they close the net from underneath? Like having a drawstring and pulling it shut? Purse seine. Purse seine. What about when they have like 1,000 hooks? Long line. What about when they have a net that's 10 miles long? And they just kind of let it drift. It's a drift net. Drift net. What was the FAD? The FAD that you read about yesterday?
Oh.
Fish aggregating device.
Yeah.
So what does that mean to aggregate? Yeah, it's a piece of technology which could actually be very simple. Though, in fact, they drew it to look like it was just a log raft. And it turns out that if you have something like a log raft out in the ocean, little fish tend to come there and hang out underneath it like they're being protected. But once the little fish are there, what does that attract? Yeah, it attracts birds, but it also attracts bigger fish, which could include tuna. And so that's what they mean by a fish aggregating device. It gathers them together. What was another one we had? Another type of fishing. What about a gill net? How does it catch the fish? Take a wild guess if it's a gill net.
The gills.
Yeah, it traps them by their gills. So the hole is big enough that the fish's head can get in there, but its body can't get all the way through. So it tries to back out, but their gills get stuck on the net. That's what they mean by a gill net.
So, would you stop eating seafood altogether?
I think I've cut down. I do use the Seafood Watch app. And so if Monterey Bay Aquarium is telling me that it's green, then I definitely will go ahead and eat it. If they're telling me that it's red, I will definitely not. If they're telling me it's yellow, I usually won't. Um,
Because I'm looking at
yeah, salmon's an interesting case because some of it's green and some of it's red.
yeah.
If it's wild Alaskan salmon, it's caught in the ocean off the coast of Alaska, then it's green. It's sustainably caught and there's a big supply. But if it's farmed Atlantic salmon, then it's red for several reasons. So you have to ask basically, is it wild or is it farmed? And if it's wild caught salmon, it's good. If it's farmed salmon, generally it's not good. The wild caught tastes better too.
Yeah.
Um,
Because at Costco, they have like wild and they have like some other ones.
yeah,
So,
yeah.
but my mom never gets the wild one because it's expensive.
That's the thing. To do the sustainable thing is expensive. And did you see that thing about the tuna? The sustainable tuna is much more expensive than the cheap Starkist dolphin killing tuna.
Now I know why. I can tell my mom because she's like, why?
Yeah, because they're catching them basically one fish at a time to make sure they don't kill any dolphins along the way,
Oh,
and then catching them in a big net.
I didn't know.
Yeah, yeah.
Because she would always ask, why? Like, why? Because it's the same. I'm like, I don't know.
Well, there you got some data. I'm going to sign off, you guys. Thanks for being here. I'll talk to you on Friday.
Bye. Thank you, Mr. Fairley.
Bye.